comes and goes. So, but I understand we can start where we left off, correct?
Correct, correct.
Okay. We were talking just about some of the just some of the fundamentals of mobile telecommunications. We'll go a little bit deeper into that, and we ended up, I think, on this slide. Let me see if I can find it here right here. Yeah, I got my start here. So that's always a good it's always a good point to do there. So let me erase that, get rid of that. So we finished up talking about just the concept of cellular. What does cellular mean? And again, it's just a convenient way to draw these hexagon cells as we show here. Let me go back. Let me go into there we go. It's a convenient way to draw these hexagons so they fit together like almost like a honeycomb. But the idea of cellular is to reuse frequencies at some distance away. And we ended up last week talking about the different handovers, and you would be handed over from one cell to another cell if you're engaged in a call. And so one radio tower would assign a channel, and as your signal gets weaker and weaker, the switch would detect that, and it would ask its neighbor. It would have a neighbor list and say, this cell and other cells around here to take a measurement. And then you'd be handed over. It would take a little bit of time to do that, maybe 200 milliseconds, which is like a fifth of a second. So your voice would not recognize that. Data doesn't care for that as much as voice. Voice can handle a little delays like that. Now, technologies today have changed, but again, we're just talking about the concepts here. And then we looked at inter-system handover, where you're communicating on the phone, assigned a radio channel out of one cell controlled by one mobile switch, and you're engaged in a call, and you now go into a cell that's controlled by a second mobile switch, and that would require a signaling to go between these two switches to set up a second voice path. So then the voice path would be through that green line to that mobile switch and that green line to that mobile switch. And then you could continue to talk. Now, this is assuming that you are engaged in a call. If your mobile was idle, this would not occur because, again, you're only assigned a radio channel if you're using your mobile phone. If not, the system recognizes you, it knows where you're at, but again, it doesn't assign any voice channels. And then we looked at these piece parts of this is where we ended up. Any mobile network, any generation, you've heard of maybe 2G, 3G, 4G, 5G, any generation is always made up of three parts. One is the user equipment itself. And years ago, that was only a mobile phone. Today, that could be a Internet of Thing device, that could be a sensor, that could be a laptop, that could be almost anything today that would use the cellular network. That's the one part, the user equipment. The second piece, the second part to any mobile network is going to be what's known as the RAN, the RAN. That's the radio access network. That, of course, it has the radio on one side and it connects up to this third part, which is the core network. Now, the core network, this is where most of the changes take place as far as hardware, as far as these different generations. A 3G looks different than a fourth generation. A fourth generation is different than a fifth generation. They do the same basic functions. They keep track of the mobile. They keep track of the mobile. They update your location. They cancel you out of other locations. They authenticate you. So there's a lot that goes on inside the core network. And that core network is made up of different piece parts, different parts to the network. And again, these parts change over time. And when we look at different generations, but the older generations had something called a central switch. Now, that switch acts like any other telephone switch. It analyzes your digits. If you want to place a call, it does other things. But again, that's one of the key pieces. It also connects to other networks. So you can communicate with someone in the wire line network, the wired network. Generically, that's called the public switched telephone network. Just a kind of a generic term meaning the wire line network. It also has voice circuits or voice paths, so you can connect to other mobile networks. So you can talk to someone else on the phone from another network. Another key part to this is to keep track of all of the users that are in this area, all of the users that are in this particular switching area. And that's a visitor register. Sometimes it's called the visitor location register. It has a copy of your profile, of your subscription information. It knows if you have any restrictions. It knows if you have any services like call forwarding or call waiting. So it knows something about you. And it gets a copy of that from the home register. So this is the central database. This home register is the central database that has all of your subscription information. So when you come into an area, you need to identify yourself. The cell tower will send that to the mobile switch. The mobile switch will consult its internal visitor database. And hey, do you know who this person is? If it knows all about you, if you've already been in this area for a while, it'll just make note of the time of day and maybe the signal strength. If it doesn't know you, if this is the first time you're registering in this system, it will send a signaling message from this visitor register to the home register. Now, that might be in your home network. It might be if you're roaming. If Raphael gets on a plane and goes to visit Richard in Dublin and he powers his mobile phone on, the visited system in Dublin will need to get a copy of his subscription profile from the home system in Accra. So this does not have to be within the same network. So that's the home register. So this device knows where you're at, and it has the master copy, if you will, the central copy of all of your subscription information. It's like the key copy, and it gives a copy to the visited system. And there are other databases that make up a core network, things that are used for authentication. When you use your mobile phone, the system wants to authenticate you. Make sure this is really who it is. Make sure that is this really you? So the network will authenticate you. There's also databases for short messages. If Raphael taps out a short message for someone, that's going to be sent to a database in his home system. That database now stores that message while another message goes out to try and find who the recipient is, where the recipient is located. If Raphael sends me a short message, that message goes to his message center in his home switch. It will then go find me wherever I'm at in the world. So, and we'll talk how that whole scheme works. But these are just some of the parts of what's in the core network. So the three parts are the user equipment, the radio access network, and the core network. Now, whenever you register into a new system, whenever you come into a new system, there's a series of messages that have to be exchanged. First of all, you power on your mobile phone, or let's land in an airplane, or it's the first time you're using your phone from you wake up in the morning, you turn your mobile phone on, or whenever you're first known in a system, your identity comes out. Now, your identity is not your telephone number. Your telephone number is what I need to call you. But the system doesn't care about your telephone number. It cares about something that identifies you and your home network. You and your home network. And that is called we'll talk more about this later, that's called the IMSI, International Mobile Subscription Identity, International Mobile Subscriber Identity. That identity identifies your home network. So if Raphael goes to Dublin and he powers his mobile phone on there, that IMSI, that International Mobile Subscriber Identity, will identify whatever his whatever his home network is in Ghana. So so it knows who your home network is. But anyway, that goes out over the air, and it's picked up by a cell tower, and the cell tower is connected to this mobile switch. The mobile switch needs to ask its internal visitor register, hey, do you know who this mobile is? If it does, it just again makes note of the time of day and everything, and the signal strength. If not, it's going to send a signaling message. It's going to send a packet of data to the home system. And it's going to ask the home system, make a copy of this customer's service profile. I want a copy of that so I know if there's any restrictions or any services they have, or just anything about that subscription, how much data they can use, and so on. So this device makes a copy of that and sends it back to the visitor register. But in addition, this home database makes note of this identity where you're at in the world. So it knows down to the switch where you're at. The home system, the home register doesn't know as you move from one cell to another cell to another cell. If Raphael is in Dublin and he's driving around the city of Dublin, the home system doesn't know where he's at. It knows down to the switch where you're at. The home register knows where you're at, the switch where you're at, and it makes a copy of your service profile and gives it to the visited system. So that's the bases. These pieces of hardware will change. There's different methods that it's done, but the basic concept is going to be there all the time. Now, once you're known, here's what happens. Once you're known, they can place calls, they can receive calls, they can send a text message, they can receive text message, they can modify their supplementary services. This would be like call forwarding or call waiting or three-way calling. These are what are known as supplementary services. They have access to something called unstructured supplementary services data, USSD. What that is let's say your home system has a keystroke where if you do *86, it automatically calls your voicemail. So you pick up your mobile, you do *86, and you get your voicemail. Well, now if you're roaming somewhere in Dublin, how does the system in Dublin know that *86 means to call your voicemail? Well, again, that's unstructured supplementary services data. The visited system will then consult the home system. Hey, what do I do with this string of digits? So all those kinds of things now are known in the visited system. Now, the serving database, the serving visitor register where you're at, keeps a copy of your your subscriber's profile as long as you're there. If Raphael is there for a week, it's going to stay there for a week. Now, normally most systems clear everyone out in the middle of the night. They just clear their visitor register. And so what happens? Well, the next time your mobile gives its identity, and that's, let's say, roughly every 10 minutes, your mobile is just saying, here I am, here I am, here's my identity. If you're cleared out of the visited system and it's the middle of the night, it'll just again re-register you back in the home system. So it kind of keeps things current. Back in the home system, though, and again, we'll use Raphael as the example. Back in the home system, he's roaming. The identity of the serving mobile switch and the serving visitor location register is known here. So any service that needs to find Raphael will always go to his home system first. What kind of service needs to know where he's at? If you call him, if I pick up the phone and call him, it's got to go to that register and go find him. If I send him a short message, if I tap out a short message, that short message in my system, in my network, in Verizon in Chicago, needs to consult the home register of the recipient network. So any service that needs to find you is going to go to that home register. So those are the basics now of mobile telephony, the basics of what is a cellular system, the basics of just the three main parts of a mobile network: your user equipment, your radio access network, and then your core network. And the core network, changes take place there with each generation. Now, changes also take place here because the radio, that definitely changes the way the signal gets modulated. The earlier systems way back in the 1980s, these were analog, just analog frequency modulated signals, just like your FM radio. Today they're digitized. Today it's a digital signal. And there's several different ways that you can digitize that. So again, there's a lot of changes here on the radio interface, but the biggest changes you'll see are going to be in this part of the network here. So those are kind of the basics. Now, what we're going to do within the next couple of weeks, we're going to look at the different generations. We'll start with the first generation, just for historical reasons. We'll take a look at the first generation, but then we'll zero in on what is a 2G? What is it made of? How does it talk? What is a 3G? What is a 4G? What is a 5G? Because these different generations, it's not like when you go and buy an appliance or you buy a car where you get rid of your old one and you have a new one. These things are very much mix and match, and some networks are still on second and third generation. Some networks are on fifth generation. Some networks maintain multiple generations. Again, depending on the area, the geography. Maybe in maybe in Ghana, in the city, like in Accra, you'd have a fourth generation, but way out in the countryside, maybe they're still on 2 and 3G, where there's fewer people and it's very remote areas. So again, it's all going to vary. But before we look at the generations, let's take a look at the mobile telecom just as an industry in the whole. Um, Most people have seen maybe a cell tower. Most people are familiar with a mobile phone. But to make this whole thing work, there's different mobile network operators out there. And there's also what are known as virtual operators. They're operators, but they're not really operators, they're virtual operators. There are companies that provide signaling services, and there are hubbing providers. If you didn't have a hubbing provider, every network would have to communicate with every other network directly. There's probably 800 networks in the world. You can't have all 800 all talk to each other. So you go through these different hubbing providers or signaling providers. There's data clearinghouses. There's financial clearinghouses. When I roam, if I go to Accra and I land in there and I power my mobile phone on, I can use the network there as long as there's a roaming agreement with my home network, Verizon, and let's say MTN in Accra. I don't know if that's it, but we'll just say MTN. MTN and Verizon, they have a roaming agreement. Part of that roaming agreement says that if one of Verizon's customers, me, flies over to Accra and uses the phone, MTN is going to charge Verizon for that privilege. I don't get the bill from Accra. I don't get the bill from MTN. I receive my normal bill from Verizon. But there is money that changes hand between the networks. Likewise, if Raphael flies over to Chicago and MTN in Accra has signed a roaming agreement with Verizon, Verizon will charge MTN for Raphael to use the phone there. He won't see that bill, but again, the networks will change money. So you can imagine there's a lot of money, a lot of things that go back and forth between these companies. So therefore, you need some kind of financial clearinghouse because Verizon might say Raphael was here for 3 days. MTN might say Raphael's never left our network. So we have to, to settle these accounts. So again, there's financial clearinghouses. We'll look at those. There's many different industry vendors. Some of those are used for like hardware vendors. Some of those are software vendors. Some of those are equipment vendors. Some of those are value-added services like Cellular, which provide roaming services, which provides analytics, which provides security services. So these are industry vendors that work with the mobile network operators. There's different aggregators, and aggregator is like we said earlier, that's kind of where things get funneled into one rather than everyone connecting together. There's a lot of different industry associations. There's industry associations like trade groups and organizations. There's different standards bodies. In order for a phone to work in Accra, and that same phone can work in Chicago, or that same phone can work in Dublin, says there has to be standards. You have to have a standard radio frequency. You have to have standard communication. If every network had their own radio frequency, if every network had their own communication protocol, you could never roam because the phone would try and a phone in Accra would try to work in a different standard, let's say in Dublin. Well, that doesn't work. So you have to have bodies or groups that write standards that are like standards. So Something works in one location will work in another location. So again, there's a lot of different things. So we'll take a look at the mobile telecom industry kind of as a group here. We'll start it today. This is a little bit dated, it's several years old. I thought it was an interesting trend here. I've not seen a newer one from this group, Statista. I think if you maybe subscribe to their stuff, there's maybe a newer one. But it looks like sometime around right before 2016 was when this trend for landline phones was going down, 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 and the trend for, and this is only households without a landline, and then many people are having only a cell phone. So that line crossed there. So this at this time period, 2022, it was this number of people that had cell phones only, and this number of people that had a working landline. Um, so I still have a landline. I have a mobile phone also, but I still use a landline. So exactly where it's at today, I'm not sure. I just thought it was a just kind of an interesting trend. Landlines, though, are not dead. Landlines are still good for emergency calls. Emergency calls, it knows exactly where you're at. It doesn't have to go out and pinpoint your location. On a mobile phone, if you dial an emergency number, a separate signal has to go out to find where you're at. On a landline phone, it knows where you're at because your landline is tethered to that street address. There's certainly privacy. You know, you certainly don't have to worry about privacy issues on a wireline phone. The quality and the reliability is still there. They used landline phones use different power sources, so even if the power is out, as long as you have a connection back to the main central switch, your phone can work. So again, they're not totally dead yet, but there's certainly a trend in people having only a wireless phone. When we look at roaming, just as kind of an overview, what does it mean to roam? Well, what it means to roam, you have, let's say, just say two networks here. So you have network, mobile network B, mobile network A, and they're going to be connected in many different ways. One of the ways they're connected together is through signaling. So that means that signals can go between these networks. This would be for things like updating your location. If her home network is here in B and she is now in mobile network A, the visitor location register here has to send signaling message to the home location register here, just like we saw a couple slides ago. So you have these signaling networks that interconnect. But from her perspective, if her home network is B right here, then from the perspective of B right here, she's an outbound roamer. So her home network says, okay, she is outbound. But from network A, where she is at, she's an inbound roamer. So those are just two terms. You have an inbound roamer and an outbound roamer. Now, we mentioned this earlier, but mobile network A right here, they will charge B, her home network, for using this service. How much do they charge? They negotiate that. They negotiate that. The fact of the matter is there's multiple um, telephone companies here in one, let's say one country or one area. Where I'm at, I can go to Verizon, I can go to AT&T, I can go to T-Mobile. And let's say in Accra, let's just say you have mobile network A, you have MTN, and you have Orange or Vodafone, or whatever your phone networks are. So you have multiple phone companies in any one area. So normally these phone companies will sign roaming agreements with each and every one of them. But maybe they get a better rate. Maybe Verizon here gets a better rate from, let's say, MTN. So any roamers going into Accra or anywhere in Ghana, let's say they want to use MTN. So her phone will try to attach then to MTN. So, but MTN will charge the home network, Verizon will charge the home network Verizon for using their phones. So you get a bill. But at the same time, any roamers from this network going into this network, mobile network B, will charge A for roamers in their network. So again, at the end of the month, it's a kind of a settlement of accounts. You owe me 100 minutes. I owe you 90 minutes. We'll settle it for 10 minutes, whatever that rate might be. Now, there's a lot of times disputes. That's why you have these financial clearinghouses in the middle. But basically, this is how roaming works. Now, let's say Raphael goes to 5 different countries, 5 different networks in a month. He doesn't receive a bill from each one of those, but each one of them will charge the home network for him using that. And then he'll get one bill at the end of the month. So the network, so money does flow between these networks. So it does require billing. It does require this roamer to bill. So if you're an inbound roamer somewhere, you've now flown into another network. It could be in your home country. It could be in another country. Let's say you go into a network here. We already know that the visitor device here, the visitor register, will consult the home register here and ask for your profile, your subscription information, which it gives back to here. Now, once you're known, though, you can use your mobile phone for voice. You can use your mobile phone for SMS, in some cases, data. So the visited network collects this information. It collects what you use, how many times you use your for texting, your short message service. It knows how often you're using it for your voice. It knows your data. It knows all of that. Now, data is treated a little bit different. We'll talk more about that later. But it collects all the information about you. It all collects your details. The visited system then puts it into a what's known as a TAP file. It's a transfer account procedures, a standardized file. And then the visited network sends it back to the home network. Okay, you owe me this much money. Okay, pretty simple, pretty straightforward. However, like number 5 shows, what about the currency exchange rates? Sometimes exchange rates fluctuate hourly. So there could be difference in exchange rates. Now, a minute here, a minute there is not bad, but you start talking thousands of minutes, it could end up being a lot of money. How about different billing models? How about different time zones? Maybe maybe this subscriber has some kind of service where they get a discount rate between 8 a.m. or let's say between 8 p.m. and 8 a.m. at nighttime. Well, nighttime in Ghana is different than nighttime somewhere the home system might be. So how do you account for that? Are you talking the nighttime minutes here in Ghana, or are you talking the nighttime minutes at home in the United States? Maybe errors, maybe disputes. So maybe one company says, hey, one network says Raphael was here for 3 days. You owe us 3 days worth of here's his usage. The home network might say, no, he was only there 2 days. We don't, we dispute that. So again, not everything, not everything is always clean cut. So that's why you have these data and these financial clearinghouses. And there are companies that provide this service, companies like Anecto, companies like EDCH, Star Home, Cineverse. These are companies that provide what are known as roaming or data and financial clearinghouses. They do things like roaming service settlement of accounts to ensure that the accounts are accurate, any revenue assurance, and they do some other things too. They manage different tariffs because to roam it takes more than a technical communication. Technically, you have to be talking to each other. So there has to be signaling, there has to be the technology there to do that. But there's also this side of it where there's the clearinghouses. So there are companies that provide that type of service. So roaming has to be, you need roaming agreements between two companies. You also need the technically to hook up with each other, but you also need things like this where you have financial and data clearing. Questions? All right, I think we are going to put a start here, right here. So we will know 1 week from today where we are starting. Oops. Whole thing. Okay. We will start there 1 week from 1 week from today. Any questions? Okay. I am going to stop presenting then. I'll clear this out. I'm going to move you over to here. And I want to thank you for your attention. If you have any questions, either send me directly, steve@celluassist.com, or contact Raphael, and he'll be able to answer any questions. So thank you very much. Enjoy the rest of your class this evening and enjoy your weekend. We'll see you next week.
Thank you very much. God bless you.
Okay, thank you. Thank you, everyone.
Thank you, sir. Thank you.
Have a good weekend. Have a good class this evening also. Cheers. Cheers. Bye.